Okay, the next sort of way of sketching interesting functions, I'll call them interesting functions, is sketching rational functions. Rational functions. Okay, sketching rational functions. And what that looks like is y equals some function over some other function, like that. F of x over g of x. So examples of that might be y equals x squared plus 9 over x cubed plus 2x or something like that. Some function divided by another function. And thinking about how we draw those and those sorts of things. It might be y equals x4 plus 1 plus x cubed. I'm just making crap up. Any function over any function. Okay. And what we do in this particular case, there's a method called adding ordinates. And what that means is just sketching each individual function. I'll show you what it means. If you can write y as some f of x, some function of x plus some other function of x, that sort of thing. If you can write y as those sort of things, then you can sketch this graph, sketch this graph, sketch this graph, whatever. It doesn't have to have a third one in there. And then you can just look at them and add their y values all together at each point. And so you look at this graph and you add the value to that, and it gives you a rough sketch of these things. And so I'll show you, of course I'll show you some examples of that. But basically, say you've got y equals, just a really easy example, y equals 2x plus 1. You know how to sketch this, but one way to be able to sketch that is to sketch the graph of y equals 2x. So I'll just get rid of y equals 2x looks like this, and the graph of y equals 1, looks like that. And then basically you can just add all your ordinates together. So if you look at this, you would go here y is equal to 0, here y is equal to 1, and so if you add them together you get 1. There you get a value of whatever, negative, and if you add it to 1 then you get that value there. If you go on and at each place you add those together, then you get this graph y equals 2x plus 1. And that's effectively what we're doing. We're just adding the two graphs together at each point. So that plus that equals that. So let's just jump into an example, much easier to see, and I'll go through it more explicitly in class. So let's have a look at, let's sketch y equals x fourth plus 1 over x squared. And so what we want to do is to try and break this up into its pieces. But before I do, I just want to notice something, that when x is equal to 0, you're going to get an asymptote here. Okay, so you're going to get a vertical asymptote. When x is equal to 0. Okay, can everyone see that? X is equal to 0, you're going to be undefined, so you're going to get a vertical asymptote. Just something to notice. Let's just rewrite this. What we want to do is write it as something plus something. And in fact, we can just divide x4 plus 1 by x squared. Now you can use long division for this if you want, but what you can just divide both parts. So what's x4 divided by x squared? That's just x squared. What's 1 divided by x squared? That's 1 over x squared. Okay, so just being able to write it like that is very helpful because we're able to sketch this. Now, if we look at this, then we can just find another asymptote, because as x approaches infinity, as x gets massive, what happens to this number here? As x gets massive, this will go to 0. And so if that goes to 0, then y gets closer and closer to x squared. And this is what we call a non-vertical asymptote. And I've been a bit slack here. I've said x equals infinity, but in fact it's plus or minus infinity, because negative infinity will also go to this particular graph here. Okay, so vertical asymptotes are when the bottom line is equal to 0. That's when you get x equals 0. That'll be a vertical. X equals 0. The line x equals 0 is vertical, and you're going to get a non-vertical. You're going to get this parabola asymptote. We'll think about what that means in a second. All right. Now that we've got this, we've written this function as the addition of two functions. I tried to make that red, but I didn't. We've got the addition of two functions, y equals x squared and y equals 1 on x squared. So now, if we get our graph, we can sketch these things. So let's do that. So again, terrible graph, I apologise. Should get my template out, I keep forgetting. Good. So just roughly, let's have a look. And I'll do both of them in green and then we can add them together. Alright. So y equals x squared looks like this. Okay. There's our y equals x squared. And y equals 1 on x squared, what does that look like? Remember, that's our truncus, so we're going to get, I'll do it in green as well, something looking like this. Y equals 1 over x squared looks like this. Okay, it's quite hard on this tablet that I've got here doing that, but that's not too bad. Okay, so there's our line y equals 1 on x squared. But what our function is going to look like, and I'll do that in blue, is going to be adding all of these things together. Okay, so let's have it. This is all positive, so this is nice at the moment. I'll do one next, which won't be, so that'll help in your understanding. But at each point, each x point, we're going to sort of put a few dots in, just to see what this thing looks like. Okay. Firstly, let's put a vertical asymptote when x equals 0. So there's going to be an asymptote down here that's on the line I'm just showing you that's there. Okay. There's our vertical asymptote when x is equal to 0. Right, let's start with this point here. These points both cross over there. So here, let's say the value is y is 1 or something for each one. You add them two together, you're going to get something up about here. You're doubling them, okay? So at each point, you're going to get twice as big. So if you can just try to think about this, try to picture it, it's quite hard. Here, the value of y is about that, but then we're going to add this y value as well, so we're going to add about that much to this. So we're going to put it about there. Similarly, here we're going to add to this y value, we're going to add that much, and so we're going to go up by a little bit. And it sort of ends up going sort of like up, like that. And remember that a non-vertical asymptote is y equals x squared. So as x goes to infinity, as x goes out in this direction, it's going to get closer and closer to the line y equals x squared. So it's going to get closer and closer to that. In this direction, what happens here? Well, pick a y value. So here, there's our y value. We're going to add the y value of the other graph, so about that much there. I'll just draw it on there. About that much is how much we're going to add to the top of this. So that'll be about there. Similarly, here, we're going to add about that much onto the top of it, so it'll go up to about there. And similarly, it's going to come up, oh, not very good, but something like that. It's going to be, it look like a parabola. It's not a parabola, but it looks something like that. And so that's what it looks like on this side of the graph. Similarly, it's exactly the same on this side. You're going to add the two together. You're going to add that y value plus that y value, so you get twice that y value, so it'll be up there somewhere. And it will go up in this direction. That's not very good, it should be flat, but and up in that direction. Terrible drawing. Hopefully you can understand it should look like something like that. Okay, going up in asymptotes. To y equals x squared, something like that. That's what it should look like. A bit messy here. But that's basically it. You find your vertical asymptotes, you find your non-vertical asymptotes, you sketch each part, and then you add all the parts together, and there you go. If you need to find any intercepts or anything like that, of course you find those sorts of things as well, just around space and time. One more example, I'm just going to check the time, speaking of the time, make sure I'm up to 9 minutes. I've got 6 minutes to do that, that's good. So example, let's have a go sketching y equals 4x squared plus x minus 8 all over x. Okay, so here we go. Firstly, pick off your vertical asymptote. So, vertical asymptote. Where are you going to get a vertical asymptote? When the bottom line is equal to 0. So when x is equal to 0. Again, sorry, I've picked a boring example, but there you go. X equals 0 will give you a vertical asymptote. If we now sort of divide through by x, again, you can do this using long division, but you don't really need to. Just divide each part by x. What's 4x squared divided by x? 4x. What's x divided by x? 1. Negative 8 divided by x is negative 8 divided by x. So you divide through by x and you get that. And so now let's have a look at non-vertical asymptotes. Non-vertical asymptotes. So as x approaches infinity, as this gets massive, as x gets massive, 8 over x, that will go to 0. That whole thing will just get closer and closer to 0. And so what will y get closer and closer to as it goes to infinity? It will just end up getting closer and closer to 4x plus 1. So it's always just this first part of your expansion here that will just go to 0, so it ends up going to 4x plus 1. Okay, fantastic. And so it goes to this diagonal line here, and in fact plus or minus doesn't matter, because even minus infinity, that'll just go to a positive, very, very, very small number, and so it will go to that from both sides. So there's your two asymptotes, and then therefore what we want to do is sketch this function, y equals that, and sketch this function here. Now, because it's a subtract here, you just need to be careful. What I want you to do is think about that as 4x plus 1 plus the graph of negative 8 over x. Okay? Just think about it like that, please, because subtracting ordinates is a lot more confusing. So always think about it as adding ordinates. Okay. Right. Let's have a look at this. Again, it's not going to be accurate. You'll do it accurate. I'm just sort of showing you the idea, the concept. Let's sketch y equals 4x plus 1. Goes through 1, and it's quite steep, so it'll be something like this. Okay, that's y equals 4x plus 1. And then we've got the graph y equals negative 8 over x. Okay, so what does that look like? Well, the graph of 1 over x looks like this. The graph of negative 1 over x looks like this, and it's going to be a factor of 8, so it's going to be quite tight, but I'll just sort of sketch roughly. It'll be something like this, and something like that. Okay, fantastic. It'll be a bit, in reality, it'd be a lot tighter to the intercept, to the axes there, but I've just, that it is what it is. Fantastic. Good. So that's the graph of y equals negative 8 over x. Now let's add all the ordinates together. So again, I'll get my blue pen and look at this. Let's add them together. Where should we start? Well, let's put our vertical asymptote. We're going to x equals 0. That is going to be an asymptote. Okay, through the middle. Better just label that x equals 0. And also, as the line gets bigger and bigger, it's going to go toward this line 4x plus 1. It's going to get closer and closer to there. Okay. Let's start over here. Whenever you've got asymptotes, very, very small lines, it's going to be closer to here. So at this point here, it's going to be something like that. Alright, it's going to be close to that line 4x plus 1, as told us by our asymptote over here. What happens as it goes up here? Well, at this point here, y is equal to 1, and up there it's infinity. So up here it's going to go to infinity, and you can see it's going to, if you add, let's take this y point here and that y point there. If you add those two together, it's going to subtract over. It's going to end up like there. If you here, when y is equal to 0 here, and you've got y that, so that point is going to be on that point there. I'll explain this better in class because it's very hard on here to show you what happens. Basically, if we add all these y points, let's just choose another one. Let's choose this y point here. That's that negative, and this y point here. If we add those two together, you've got a positive. Let's just say positive 1 there, and you've got negative 3 there. It's going to end up being a negative number, so it'll be about there. Okay, so it's going to roughly go up and closer to that line there, x equals 0. So you can see here that gives you your asymptote there of y equals 4x plus 1, and up there to x equals 0. So that's what it will look like there. What happens here? If you think about it, if you pick a y point, let's pick a y point there, and the y point there, corresponding y point down here. What will they do? They almost negate each other, but it's going to end up being roughly about there. Okay, so it's going to subtract off them. It'll be in between those two. As that gets bigger and bigger, negative here, and that goes closer and closer to 0, it's going to get closer and closer, sort of, to this line like that. Okay. Here, this y, well, let's just pick another y point here and a y point here. This is getting smaller and smaller, so it's getting it's going to take about that much off it, and in actual fact it comes up. Oh, that was bad. It comes up through here and gets closer and closer to that asymptote up like that. And so that's basically what that graph looks like. Again, explain it better in class, but you just add the 2 points together and you come up with a rough sketch of what that looks like. Of course, you'd find your x-intercepts to help with your sketch. That will always help. But that is how to add ordinates.